Hey, what's up guys? Welcome back to another video on the Mindstorm Minecraft server development series. In this video, I'm going to teach you guys how to do event listeners. So I just want to first of all say thank you guys so much for the support on the last video, the first video of the series, creating your very first Mindstorm server. It got over 3,000 views just under 24 hours, which is just crazy for me as a small channel. And yeah, the support on that was crazy, and I really thank you guys for sharing the videos and also just liking the videos and watching, okay? Thank you so much. But from that, I was able to tell that you guys are excited about this new stuff here because it is really cool. And I'm also very excited as well because, just the stuff that this has is really game changing for creating, custom experiences with Minecraft servers. So when we learned how to create the server last time, we, created the server, set up the world, told it how to generate the world, added lighting, but we also used this thing called the global event handler and added a listener to it that will listen to the async player configuration event. So we're going to focus on this aspect of things, event listeners. So what is an event? If you don't know what it is, the most high-level basic definition of event is just something that happens. I know it's kind of broad, but it could be anything like player events, so player breaking blocks, dying, like anything that a player can do. And then you have other events for literally everything that happens on a Minecraft server, just every aspect of a Minecraft server. So what I'll actually do is show you guys how to see all of the events available to us. So if we head to the mindstorm.net website and we go to JavaDoc, these JavaDocs here gives us all the documentation for all the stuff that we have available to us in the Java code for the library. So if we just go down to net.mindstorm.server.events, this is the root package for anything event related. So we can click that. And that breaks down into different types of events. So we have the player event, like I just told you about. We have server events, item events, inventory events. So like opening an inventory, closing an inventory, clicking an inventory, changing the items in inventory, all kinds of stuff like that. We can look at entity events. So entity death event, despawn event, all kinds of stuff like that. Player. So there's a lot more for player because those are probably the most important ones, I would say. But the point here is that we have all of these things that could happen in game, like in Minecraft, and these events are classes that represent something happening. So if we look at the player block break event, this represents a player breaking a block, okay? And so since we have these events, what is really cool about that is that we can add listeners. We can listen to these events in our server code so that whenever these events happen, we run whatever code we want to run. So in this specific example here that we already did before, we're adding a listener to listen for the async player configuration event, and then we're giving it a block of code that will be run every time that this event is triggered. So the server will always be listening to events. When this particular event happens, we'll run this piece of code here, okay? And so if you want to find out what this specific event does, you can look at the JavaDocs, or you can do Control Q, and you can check out the JavaDocs within your IDE. It may say like at the bottom like download JavaDocs or something like that. Just make sure you click that for the first time. But it says called when a player enters the configuration state either on first connection or if they are sent back to configuration later. The players move to the play state as soon as all event handles finish processing this event. So what this means is that basically this is the event that is triggered when a player first joins the server so that you can set up their configuration. So in this case, we're getting the player that joined the server, we're setting their spawn world, and then also where in that world we're going to spawn them. So the capability of being able to listen to events using event listeners gives you a lot of cool stuff, a lot of capability, because you can have your server do stuff that otherwise it would not do, obviously. So if a player dies, for example, there's the player death event, you could listen to that and then run some custom code every time a player dies, like taking money away from their account, print a message to the chat, anything like that. So you have a lot of options, okay? So the global event handler is just the basic way that we can add event listeners. So let me go ahead and add another one. When we joined the server last time, we saw that whenever we broke a block, it did not drop anything because that's unimplemented. So the way that we can implement that is by actually implementing the block break listener and customizing, what happens when you break a block, which should be to drop the actual block as an item, right? So let's go ahead and figure that out. So we're going to do global event handler. And then we can do a bunch of stuff here, but the ones that we really care about at the moment is add listener. And now what you want to tell it is what class you're trying to listen to. What specific events are you listening to? So player block break event dot class. And you can find all these names, of course, like I said, on the JavaDocs, or just, typing them out using the autocomplete is also very helpful most of the time. But yeah, once you have told it what class you're going to listen to, what event you're going to listen to, now we can give it a lambda, a consumer, which is representing what happens when the event is listened to. So we can just do events, arrow, and then open the curly brackets, or you can do control space and then just press tab and it will autocomplete all of that for you. So one thing I like to do though, which is very common, is change this name here from this long name to just event. It's just easier to call it that way, or E, whatever you want to name it. But yeah, this variable here represents the actual event itself, and it gives you all the information from the event. So we can do event dot, and you can see that it has all this information here. So you can see the block that was broken. It even tells you in the documentation. You can see the player who broke the block face, the block position, so the XYZ coordinates of the block. You can cancel it, which we'll talk about in a second, but all kinds of cool stuff, right? So that's how you extract information when an event happens, which is very helpful. So let's put that to the test. We're going to do S out. We're going to do events.getPlayer, the player who broke the block. Let's just go ahead and get their name. So get display name, and we'll say has broken a block. And this code alone should add an event listener that should listen for the player block break event, okay? So let's go ahead and start the server up and join it and see if it works. All right, I'm on the server now, so let's try breaking a block. Okay, so as you can see, nothing dropped, but if we check our console now, it says null has broken a block. So that's weird. It says null instead of the actual display name. So, and it explains it here. So when we do control Q to see the documentation, it says it returns the player's display name. If it says null, this means that the username is displayed instead. So I'm assuming what that means is that a display name has not been set for the player. That's why it doesn't have anything to show. So I'll go ahead and do get username instead, and that should fix it. Let's try it again. Okay, back on the server. Check the console. There we go. So it says Illuminati has broken a block. That's my name. And there we go. That's how you can make a simple event listener to listen to the player block break event, which is simply listening to events. Pretty cool, right? So now let's make it so that it actually does what you would expect on a vanilla server. So it actually drops the block that was broken. I'm going to make a more detailed video on items, but for now, just try to follow along the best you can. And I'll explain it as I go along, okay? So the first thing that we're going to do is do var material and just get the material of the block that was broken. So get block.registry.material. I'll also have a video on blocks as well. I'm going to explain as much as I can. So we're getting the material of the block that was broken. So for example, if we broke that grass block, it would just be grass_block. Material is an enumerator. So we can do material. If it's not null, we can go ahead and do var item stack. So we're creating a new item stack.of material. So we're saying create a new item of the type material. So it should be like a grass material item stack. And then now we want to do an item entity. So item entity is equal to new item entity. And this we're passing in the item stack. So this represents the item, but this is actually an entity that will be spawned on the server. So an actual like floating item icon thingy that, you know, appears whenever you drop an item, for example. That's what that is. So that's the item entity. So we're creating that item entity out of the item stack with that material. And then we need to tell the item entity where to spawn. So set the instance of it, set instance. We're going to set it to, we can set it to the instance container, the one that we created above, or we can make it so that it works in any world. So we could do like event.get instance. So you can get the instance from the event itself, the instance that the block was broken in. And then also to set instance, it's asking for the spawn position of this item entity that we have. And we could do that by doing event.getBlockPosition. So that will get the block's position where the block was broken and spawn that item entity in that, you know, coordinate. And then the last thing that we want to do is add something called the pickup delay. So item entity.set pickup delay, and we'll do duration.of millis 500. So thankfully someone on stream explained this to me. Otherwise I would not have figured this out very easily. Basically the pickup delay is how long after dropping the item before you can pick it up. That's pretty self-explanatory, but if you don't have it set, then you can't really drop the item because you instantly pick it up, or it just doesn't work at all. So it's really weird. I don't know how you're supposed to just know this, like without any like direction, but yeah, you gotta have that or it just won't work, okay? So make sure you have that. So we're saying as soon as we drop this item, it has 500 milliseconds and then it can be picked up by a player or someone else. And you can customize that number to be whatever you want. I think 500 milliseconds is the actual number that Minecraft uses, but I could be wrong about that. But yeah, this is everything that we're going to need to spawn the item after breaking the block, okay? So just as a little recap here, we're listening to the player block break event. We're going to print a message to verify that it has occurred, and we're listening to it. And then we're going to get the block's material. So we're storing that in a material variable. If it got it, then we're going to create a new item stack of that material, create a new item entity so that it can actually appear on the ground as an entity using the item stack, which we'll talk about more in a future video. Then we're going to set the instance of the item stack, so tell it where to spawn, the position in the world, right? And then we're setting the pickup delay of the item entity to make sure that we can actually drop it and then pick it up after 500 milliseconds. So I know a lot of you who are watching these videos are familiar with like Bukkit and stuff like that, but for those who have never done any sort of Minecraft programming before, this may be a little overwhelming because it's a lot of information here, but I promise you the more that we make stuff like this and the more videos that you watch, you will start to understand it, okay? Anyways, let's actually go ahead and test it out by restarting the server and try breaking a block, see if it drops some grass. Okay, I'm on the server now, so we're gonna do boom, and if you look closely, there is a floating little block here, so it works perfectly. Look at that. So they're just hiding in the corner, and then you can see that as I pick it up, it just disappears. That's because we have to listen again to another event for the item pickup event to make it so that whenever an item is picked up, it actually adds it to our inventory. So again, nothing is implemented. We have to implement it ourselves. Pretty cool that it's working though. So to make it actually appear in the middle of the block, as you might expect, not in like the corner hidden, you just have to go back to your code, and in the place where we're setting the spawning XYZ of the block, or of the item rather, we can do add, and then we could do 0.5, 0.5, 0.5, and that will just center it for us. There we go, look at that. Beautiful. Alright, so that's how you can create event listeners and add them to the global event handler. Very useful stuff. Now I'm going to teach you guys about event nodes. So nodes are a way to organize event listeners and create conditions for them. All right, so not only can we create event listeners like we've done above with these two things here, but we can create something called event nodes, which can sort of encapsulate them and organize them into different ways essentially, okay? So to create an event node, we can do event node, and then it wants a generic type, so we're just going to go ahead and do event. We're going to call this the all node. And we're going to say event node from Mindstorm dot, and we have all these different options here. We're going to do all, and we're just going to give it a name. So we're naming the node. We're going to call it all. Yeah, just all, that's fine. So again, a event node is just a way of organizing your event listeners. So an event node can have listeners within it, okay? So since we're doing event node.all, we're basically saying that this can have event listeners of any type within it, okay? So just like our global event handler can have any type of listener, so can this event node. The reason though that you would want to have an event node is just to organize listeners into this little thing here. So even though they're a little bit similar in the sense that they can accept any listener, it creates organization because you can have different nodes and different nodes can inherit from other nodes and all that kind of stuff that we're about to talk about, okay? So with that said, we can do all node dot, and we have all these methods here. It's actually a lot, but one that we care about is called add listener, the same one that we used above, which we can use to add a listener to our event node. So we're going to add the pickup item event listener, or class rather, and we're going to implement the pickup item event so that we can actually put those items that we pick up into our inventory, okay? So just like before, this event here will have all the information about what happened or what the event contains. So event dot, we have the living entity, the person that actually picked up the item. A living entity can be stuff like a player or just other types of entities. The item stack that was actually picked up, the world, the instance rather. Then we have get entity, which I believe is different from living entity. Living entity is the person who picked it up. Get entity is actually the item entity itself, but you also have get item entity, so I don't know the difference. Anyway, so let's just go ahead and print out a message. Player picked up an item. Okay, and then once you have the code for your event listener here, it's now part of this node, right? Because we used add listener, but now this node here is just kind of floating in space. We have to add this node as a child under our global event handler. Since the global event handler is the global event handler, this is the thing that encapsulates all of the event nodes that we can use to listen for events in our server, right? So any event node that we have that we create custom, we need to add as a child just to that, okay? And we could do that just by doing global event handler dot add child. So we have add listener. Now we're going to use add child, and we can just pass it our all node thingy. So what that will do is add our event node, but since our listeners are inside of that, it will also add our listeners, okay? So if we go ahead and rerun the server now, so we should be able to break this block and pick it up. And then in the console, there we go, it says player picked up an item. So it worked. So now we're able to create our very own event node, add a listener to it. And yeah, so you can add as many event listeners to this node as you want to. You could organize it however you want to. So it makes more sense, in my opinion, to add listeners that sort of go together. So if you have like a mini game or something that's running on your server, then you can add all the listeners, relevant to that mini game to the, event node with like mini game node or something like that. Okay, so just put them together is what I'm trying to say, because of course a event node is a way of organizing listeners. Okay, but yeah, let's go and actually finish implementing this event listener here so we can actually pick up the item. So whenever the player picks up the item, let's go ahead and get the item that was picked up. So var item stack is equal to event.get item stack. And then now we want to, well, we have event.get living entity. I happen to know that a living entity can be a player. This is just kind of one of those things that you learn as you start working on stuff like this. So if you do something like if event.get living entity is an instance of player, that's just using instance of pattern matching. So it's saying if the living entity who picked up the item is a player, then cast that to a player. Now we have this player variable. So now we want to do player.get inventory.add item stack. Pretty simple. So we're listening to the event, printing out a message, getting the item stack that was picked up, and then getting the player who picked up the item stack if it was a player, and then adding it to their inventory, because right now it doesn't. We're actually implementing that logic. Okay, so let's go and restart this and see if it works. All right, pick it up, and boom, there we go. We have picked up our grass block, and we can actually put it down if we want to. Perfect. So now we have not only figured out how to add a listener to our event node and add that event node to our global handler, but we can also now pick up items. So pretty cool stuff. So something that event nodes is also good at is, like I said before, you can create conditions for them or filters. So let's go ahead and create another events node. We're going to leave the type as a question mark for now, just for now. We can call this the player node. So the player node is equal to events node. And we have these different methods here. So before we used all, because we want to target, we want to allow this event node to have all listeners within it of any type. But the thing that we can do now is also have it filtered by different event types. So if we do event node.type, double click that to complete, we can give it a name first of all. So every event node needs a name. We can call it the players event node, for example. And then now we can set a event filter. So this is how you want to filter the events that are allowed to be part of this event node. This gives you another layer of organization for your event node. Okay, so what this means is that not only can you put whatever listeners inside of this event node that you want to organize them in whatever way you want, but you can also have it be a specific type of event. So for example, we can do event filter dot with these different options here. So we have block, we have all, entity, instance, inventory, item, and player. So these are all the main different event types that we showed before in the Java docs, if you remember. So if we were to set it to, for example, player, now what this means is that this event node can only have within it listeners for player related events. Okay, and then now with this question mark here, just change this from a question mark to player event. It's also kind of easier if you just do var. That way you don't have to worry about setting the type manually yourself. But yeah, so now we have this player node here. Like I said, it can only have within it listeners for player related events. Of course, if you're curious on like what is a player related event and what is not, you can again go back to the Java docs. Let me pull that up again. Event. We have these different categories that corresponds to the filter, the event filter I just showed you. We can look at player, and then if you just click one of these, like the player block place event, you can see that it implements the interface player event, also a bunch of others, but player event. Click that, and so here's all of the events that implement this interface here. So these are all going to be the events that are going to be allowed to be inside of your event node if you listen to them, okay? So we can do something like player node dot add listener, and we can do the item drop event. I just happen to know that's a player event because I checked ahead of time. Another way that you can tell really quickly is by holding control and just click this, and you can see that it implements the player instance event, but if you click this, this implements the, or extends the player event. So you just know that it's a player event, okay? If you don't do a player event, if you do something random like the entity tick event, for example, this is gonna warn you right away because it doesn't pass the filter, the events filter of player, okay? So it's just smart enough to know which ones you can add a listener for and not, which is awesome. Anyway, so just like before, it's the same process for actually handling this. So we can do events, open that up with a lambda, and then now we could say player dropped an item. There we go. And so now we have added a listener to our player node, which is a events node that filters out anything that's not a player event, okay? And what we can do is add this node also to our global event handler so that we can actually start listening and test this out. Because if you don't do that, it's just like I said before, floating in space. You need to actually add it as a child somewhere, okay? All right, I'm back on the server now, so we can test it out. So let's go ahead and break that, pick it up. Now we'll try dropping it by pressing Q, and disappears. Nothing happens because we have not implemented it yet. But if you check the console, it says player dropped an item. So this is working perfectly. So yeah, that's another way that we can create event nodes, is by doing event node.type, so that we can filter out or keep only the events that match this event filter. So player, for example, right? Pretty cool stuff. So let me show you guys how you can implement this one as well. Don't focus too much on the code actually part of the handler, because again, this video is supposed to be about event listeners, not like entities and stuff like that. So focus more on the listener part of this, but I'm sure you're curious on how to do this as well. So like you saw just a second ago, when we pressed Q to drop the item, nothing happened. So that's the part that we actually need to implement. So we're going to create a new item entity, just kind of like we did above when we broke the block. We wanted to spawn an item, right? So we're doing item entity is equal to new item entity. And from the event, we can do event.getItemStack. So we're getting the item that was dropped, creating an actual entity out of it that will appear on the floor. And then we can do event_entity.setInstance, just like we did before as well. Event.getInstance. And then now we want to set the spawn position of the item entity, right? And you have to kind of think about this. It doesn't just like appear somewhere like on the floor. It appears out of the player and like launches out of their body, right? When you drop an item in a regular world. Because it just like the little animation, right, if you throwing an item. So the spawn position of this item entity that we're spawning should be in the player basically, and then have a velocity where it moves outward, okay? So this is again getting a little advanced, so don't freak out too much if you don't understand what I'm saying here, but let me just show you what I mean. So we're gonna do event.getPlayer.getPosition. So this will get the XYZ position of the player. And then to actually make it move, like launched out of their body, we can do item entity.setVelocity, and we can do event.getPlayer.getPosition.direction, and then multiply by 6. So what this will do is get the XYZ position of the player, get the direction as a vector, which is getting a little into like math and stuff like that, and then multiply that vector by 6 to give it a higher velocity. So it should, go farther and faster. So that's what that will do. A little complicated. And then something that you can do to improve this is you can go to add position, you can do add, and you could just add onto that to make it a little taller. So it should launch not from the bottom of their feet, but like from the middle of their body pretty much. So after that, we can now do item entity dot set pickup delay. Same reason as before. We do not want to have an issue where we can't pick up the item. So that will make sure that it works. And that's it. So let's go ahead and test it out. All right, we're back on the server now. So let's go ahead and pick this up. Boom. Let's go ahead and drop it. And boom, it dropped. A little laggy there, but it dropped. So you can see that it's not really going too far. So what you can do is have some fun with this. The whole point of Mindstorm is to make it as customizable as possible. So you could really have some fun with this. If you want to, you could multiply it by like 20, and that will obviously increase the force in which it's thrown pretty much, the velocity. So let's try this out, see what that looks like. Boom, let's throw it, and look at that, it goes way farther. So we can pick it up, play catch with ourselves. So look at that, just launches now because it has a crazy velocity. So let's make it like really high, like 2,000. I don't even know if it's gonna appear if we do that. Let's try it out. Let's send this item to heaven. How about that? Boom, look at that. Yeah, it never came down. That's crazy. Look at that. It's so fast that it just disappears right away. That's crazy, man. All right, but yeah, that's how you can add custom functionality and implement the drop item event. But that's also, again, how you can add a event node that filters out only for player events, okay? So the last thing I'll show you guys is not only can you add a event node that filters out only specific events, but you can also add conditions to that as well. So you can filter and add conditions. So what we're going to do is do var, and we're going to just call this something like grounded players node. It'll make more sense in a second. And for this, we can do events node dot, instead of type though, we can do dot value, and then we can give it a name. We can call it grounded players. And then we can do event filter dot, and we can choose whatever type of filter we want. Let's just do player again. And then onto this, we can also add something called a predicate. A predicate is basically just a function that evaluates to true or false. So this will give you a player who is part of the event. And basically what you can do here is give it a condition. So these events that you add as listeners to this event node here will only apply to players who pass this condition. So for example, we can do something like if player.is, and we have all these different booleans here, like crazy amount, like is glowing, is invisible, is on fire. So you can basically have listeners that only apply when the player is on fire, for example. We can do is on ground. So we can do return true or return false. We could simplify this as well, like that, and then like that. And so now we can add whatever listeners we want to add to this, as long as they're player listeners, because we still have this filter here. But these listeners will only apply to players who are on the ground, okay? So this is something that you cannot do with other frameworks. Like having these built-in conditions for your event listeners is just really, 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 really cool stuff that I've never seen before. Let's add a listener that can, test this out. So grounded players node dot add a listener. And let's go ahead and do the player start sneaking event. So as you can imagine, this is an event that is triggered whenever a player starts sneaking. So when they press shift, so let's add the thingy here for that, the lambda. There we go. So we'll just print out some code. We'll say player started shifting on the ground. Before we can test it though, we need to make sure that we register this grounded players node that we have. So let's just add it to the global event handler as a child. So we're going to do global event handler.addChild.grounded players node, just like that. And then we'll join the server and see if it works. Okay, I'm on the server now, so I'm going to try shifting while in the air. So boom, so that should have done it in the air. And look, in the console there's no message, but if I do it now on the ground, boom, then there we go. We get player started shifting on the ground. So as you can see, it's only applied, the event listener is only applied when the player is on the ground. So that's just one little tiny basic example of how you can create event nodes that can not only filter out certain events, but also filter out events for specific players or whatever the event is about. In this case, because it's a event node filtering for players, it's going to be based on a player. So that's the basics of event nodes, the different ways that you can create them and add listeners to them. But something important is that you can create a hierarchy or organize them in a way where you have parent nodes and then children nodes under that parent. We're already kind of doing that with the global event handler. So we're doing global event handler.addChild, and we're just adding each of these event nodes as children. But we can also do the same thing with any event node that we have. So if we want to make the grounded players node a child of the player node, we can do that, which kind of makes sense, right? This is a player event node, and this is a player event node, except that it's filtering out players that are only just on the ground. And when you have an event node as a child of another event node, it inherits all of the filters and stuff like that from the parent, okay? Just as you might expect. So let's go ahead and try this out. So instead of doing global event handler.addChild for the grounded players node, let's go ahead and make it a child of the player node. So all we gotta do is do player node.addChild and then grounded players node, just like that. We can do the same thing for the all node and player node as well. So we can do all node.addChild player node. We just need to add it right here, of course, wherever you want to have it, but we'll just add it right there. So now the relationship is like this, where you have all at the very top. So this is allowing all events of any type. And then under that, as a child, you have the player node, which is going to allow all player events. And then as a child of the player node, you have the grounded players node, which will, of course, like I said before, do players that are on the ground. Even though this is a very basic example of how you can create these hierarchies and have like a tree of different nodes set up however you want it to, this can get very complex, of course, right? And you can use this to your benefit to organize your servers, organize the way that your servers do event listening. So you can have it as a hierarchy depending on what you're trying to do. So let me just show you an example so it's a little more clear to you guys. This is available on the Mindstorm documentation. So just as an example here, you have the server, and then within the server you have a lobby event node and a game event node. And then within the lobby event node, which represents the ranks of the server, you have the default rank, the VIP rank, and the admin rank. These, you can kind of make up what these will do, but you can probably imagine that these event nodes here will target specific players with these ranks here and apply different events to them depending on what rank they have. You also have game, and then within game you have a Skywars game, And then depending on the kit that they have, you have these different, event nodes here as well. So same kind of concept. Here's another example here. This is how they would recommend that you structure your project. That way you have good documentation, and also it's clear how the event nodes are filtered based on the inheritance of the different event nodes. So use packages for major nodes, and then use classes for minor filtering. So you have the top level server package, and then you have global, which I would assume is the global event node. And then you have lobby, rank, and then you have these different ranks that could represent the different event nodes. And yeah, so this is how you can organize your event listeners for your server. This is obviously much more complex than what we're going to be handling in this episode, but it's just important that you know why event nodes are important, and then also how they can be used in the future to enhance your project, okay? So with that said, I want to show you guys a couple more things before we end this episode. I know we've learned a lot so far. So now I want to show you guys how you can make your event listeners even more advanced here. So instead of just using a Lambda and just having the code that will be run whenever this event happens, you can build a more complex event listener. And let me show you how. So let's just get rid of all of this and replace it with event listener.builder. So as the name implies, what this will do is allow you to build a event listener, but with a lot more options. That makes it a little more advanced. So instead of the builder here, you're just going to pass in the event type that we're trying to listen to, which is the player start sneaking event dot class, same as before. And then now we could do dot on the builder, and we have these different methods here that we can use to give our event listeners a little more customized settings here. So let's just start with handler. So handler, double click that to autocomplete. This will be the actual event listener code that we had before. So this is just looking for a Lambda, a consumer. So we can control space to complete that, open that up, and then we could again print out a message, player started sneaking on the ground. And then once you're done doing everything with the event listener builder, just make sure that you do .build at the very end. That will actually build it and then provide it to the add listener method that you're calling. So let's test this out just to make sure that it works still. But so far this is doing the exact same thing that we had before. Nothing is different, just the syntax. All right, we're back on the server now, so we can start shifting. And there we go. We get player started sneaking on the ground, player started sneaking on the ground. So it's working pretty well. But let's take a look at these other things that we can add. So we can do dot, and we could do expire count. And if we check the documentation, it says it removes this listener after it has been executed the given number of times. So if we set the expire count to 3, this means that if this event listener here is fired 3 times, it will remove it from the node. So it will no longer listen to that event, okay? So let's go and try this out. Okay, we're back on the server. We're gonna shift, shift, and shift. So we get it 3 times, and then if we do it again, shift, let's do it a bunch of times, nothing else happens, because after the 3rd time, since the expired count is 3, it removed this event listener from the node. So that's really cool. This is not something I've ever seen in another framework. Maybe it exists out there, but I have not seen it. Basically, you've given a event listener a way of expiring itself or removing itself from the from event listening. So that's pretty cool. Another thing that you could do is the expire when. So expire when is very similar. It's not taking a count though, it's taking actual condition. So when this condition becomes true, then it will actually remove itself just like before. So we can try this one out. It's asking for a predicate, which is basically a Lambda that evaluates to a Boolean, true or false. So we can autocomplete that. So we're given the player start sneaking event, which is the same thing that we have down here. So this contains all the information about the event that we're listening to. So we can use that to evaluate some Boolean or condition that we want to have that will, when true, remove itself from the event node, okay? So just something basic that we can do is if the player is holding a specific item, let's say that we expire this, okay? So we can do something like if event.get, oops, not event, player start sneaking event.get player, so get the player who started sneaking, let's get their inventory, get the item in their main hand, get the material of the item, and then say if it equals material grass block, that's the only block that we have on our server. If that's true, if that is true, then we're just going to return true, and we'll also just send them a message. So player start sneaking event dot send message or get player dot send message, and then otherwise, if that condition is false, then return false, so it will not expire. Okay. So just as a recap here, what this will do is build a event listener for the grounded players node, and what it will do is basically listen to every single player start sneaking event. But after the 3rd time, it will expire, so it will remove itself from the event node and no longer be listening. Otherwise, there's also a condition that when it becomes true, it will also expire and remove itself. So the condition in this particular circumstance is that whenever the player triggers the player start sneaking event, and they also have a grass block in their hand, it will expire, and it will not hit the listener. It will remove itself, okay? Okay, we're back on the server, so let's go ahead and shift, shift, And then let's get a grass block in our hand here. So it says we shifted twice, that's good. And then if we shift again, it says you found a grass block, good job. If we check the console, it did not print the player started sneaking on the ground message because it expired before it was able to reach the handler here. So it checks the condition before it reaches the handler. So since it expired because this became true, it removed itself and it didn't hit the third time. So basically this event listener that we have here has two ways of expiring. Either it hits 3 times or it expires because the player is holding a grass block, okay? Something else that you can do is add a filter. So similar to how we're adding the filter to make sure the player's on the ground for the whole event node, we can also add filters on specific event listeners as well. So we can filter, and this is going to be a predicate with the events, just like the one above, except that whenever this is, whenever this occurs, it's not going to expire. It's just going to, filter out whether this is going to handle or not, okay? So we can do player start sneaking event dot get player. And we could just say if they're glowing or if they're eating or something like that. If they're eating, then return true. And all this code here will do is that if this is true, if this evaluates to true for the filter method, this means that this will not handle, okay? So this means that it will only apply to players who are currently eating, okay? So this is just another way of adding another layer of filtering on your event listeners, which is really cool stuff. And that's all I want to show you guys for the event listener builder. That's how you can build more complex event listeners rather than just having the like up here where we do the class and then just have a lambda. That's a really good way of doing it, but if you want to have a little more advanced settings like the expire count, expire when, and filter, you can use the event listener builder, okay? All right, so the last thing I want to show you guys, I know this episode is getting pretty long, is how to cancel events. So something that you can do is if you go to any event that you have and just hover over it actually, it will tell you the different interfaces that it implements. And sometimes you will see that some of them inherit from cancelable event. And that simply means that an event can be canceled. And what that means for us is that whenever you have an event that is cancelable, inside of the handler, you can do event.setCanceled. And what this will do is if you call this and pass in true, this will cancel the event and make it as if it never happened. So in this specific example here for the player block break event, if we cancel that, this means that the player cannot break any blocks. Nothing will happen. It will look like nothing happened basically, okay? All right, I'm back on the server now. So if I try breaking a block, nothing will happen. So it cancels, and this means that the block will not be broken. So that is what it means to cancel an event. You can do that to many of the events that we have available to us. Some of them you can't, but a lot of them you can. And this is very useful actually because you can prevent the player from doing stuff. So just as a very basic example here, if on a Minecraft server you have a player like in the spawn area and you don't want them to be able to break stuff in that area, you could check to see what coordinates they're in, and if they're in that specific coordinate zone, then you could cancel the block break event so they cannot break a block in that area. That's just one example of how this could be useful, okay? Another thing is if you want to have a server where a player cannot hit other players or hurt other players, you could cancel the player damage entity event or whatever that would be called. That way when a player smacks another player, nothing can happen because the event is canceled. Usually you will have some if statement controlling whether to cancel this or not. It will check something, and if that is true, it will cancel the event, otherwise it will not. In this case, since we have no condition here, it will cancel anytime a player breaks a block no matter what. So, and yeah, that's pretty much it for this video, everybody. I really appreciate you guys watching, and again, thank you for all the support. Hopefully you guys learned a lot in this video as well. Now you guys should know how to do event listening, how to do event nodes, which is really cool. It gives you a lot of organization and capability for filtering out different types of events and adding conditions as well. And finally, you guys should know how to use the event listener builder and also how to cancel events. All very useful stuff, and I hope you guys can use that to make your Minecraft servers even more advanced. Stay tuned for more videos, everybody. More to come. Very exciting stuff. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.